let's see the power transmitted by a belt, right? Power transmitted by a belt. So the purpose of the belt is to transmit the power from one location to the other location, right? So power may be generated in one place and it needed to be transmitted somewhere far from the generated point, right? That's the purpose of the belt drive, right? Not only belt drive, chain drive, gear, right? Purpose is that. So now we are going to see how much is the power transmitted by a belt drive, how to find that, what's the formula. All right. Let T1 and T2 are tensions in the tight and slack sides. T2 slack side tension. Slack side is the tight side where tension is low, and tight side the tension where the tension is high, and tight side is the side which is approaching the driving pulley, and slack side is the side which is approaching the driven pulley, right? And these are given in newtons. R1 and R2 radii of the driver and follower respectively, right? If we consider this as R1, the driver, and the radius of driven as R2, right? V is the velocity of the belt in meter per second, right? So the belt is moving with the velocity V meter per second, right? We'll see how to find the power transmission. The effective turning force at the circumference of the follower ring is the difference between these two tensions, right? So effective turning force or driving force. Effective driving force means if you consider only the follower, right? Only the follower, it has this side T1, okay? Opposite this side, it has T2, right? So if it is opposite, I'll put minus, right? We are considering only this portion. If this portion, if you see, since this is moving this way and this is tight side, tension is in this way, right? That is T1. And there is another tension on the top side, that is slack side tension, that is T2. So if there's a T1 tension this way and T2 tension that way, the resultant of this would be T1 minus T2, right? Because these two are acting on the opposite directions. And we know this is higher than this one. So that's why it is T1 minus T2, right? So this T1 minus T2 is the effective tension or effective force on the circumference of the follower, right? Why we are considering follower is the power is generated here on the driving, but it is transmitted to the follower, right? So we need to find what's the power transmitted to the follower, right? So that our concentration is somewhere here, not here. So this is the effective driving force. We know work is equal to force into distance, right? Work is equal to force into distance. So work done in 1 second, right? Or work done in particular time can be given by, right? So this is force into distance. That's a general formula. So if you want to know the work done in a particular time, say for example, some 1 second or some particular time, what we'll do, we will divide it with that amount of time, right? So if this is the work and if this is for 10 seconds, right, the total work done for 10 seconds, if you want to find the work for 1 second, what we'll do, we will divide it by 10, right? So which means we will divide it by t, that is time, okay? T is time, small t, yeah, capital T is tension. So we know d, that is distance upon time, equal to velocity, right? Distance upon time is equal to velocity. So work done in particular time can be given by work into velocity, right? Work into velocity. So that's what given here. Work done per second, that is in a particular time, is equal to T1 minus T2, right? So that's the resultant force here, into V. V is the velocity of the belt, right? Newton per meter second, right? So work done per second and power are the same, you know, right? So work done per second is called as power. So power is also P is equal to T1 minus T2 into V watts, right? T1 minus T2 into V watts, right? Because 1 Newton meter per second is equal to 1 watt, that we know, right? So power transmitted by a belt is given by P is equal to T1 minus T2 into V. Here T1 is tight slide tension, T2 is slack side tension, and V is the velocity of the belt. A little consideration will show that the torque exerted on the driving pulley is T1 minus T2 into R1. Similarly, torque exerted on the driven pulley is T1 minus T2 into R2, right? So we know torque is equal to force into radius. So resultant force T1 minus T2 into the radius R1 or R2. So if it is for driver pulley, that is R1. If it is for driven pulley, that is R2, right? So that is the torque exerted. Power is T1 minus T2 into V, and torque is T1 minus T2 into R, right? So this is the formula for the power transmitted by a belt.